So today our topic is storage classes. Okay. As per the definition, you can see here it is written in C language to fully define a variable. Fully define completely, right? We have to define its storage class along with its data type. So what we have done till now? Till now we have also defined variables. Like you can see here on my screen. If I have written here int I, space int I. So what is this? This is also definition of I. Definition of I, right? As an integer variable. Definition of I as an integer variable, right? That means I can store any integer value defined within the range of integers, and memory space is also fixed according to the data type. So why this is working if it is not fully defined? It is actually in computer science, in C programming, and generally many programming languages, whenever user is expected to do something and user is not doing the same, then also compiler or interpreter or that language helps user by giving some by default representation, right? For example, in functions, if you have written suppose like this f1, right? Right, this is the definition of a function you have given. So what is return type of this function? Int. By default it is added by compiler. If you have not given here any data type, so by default it is return type is integer. Similarly, in declaration or definition of a variable, generally definition of a variable, if we have not given any storage class, then it is assumed to be auto. This is also given according to the place where you have defined this variable, or you have given a value also, suppose 12. So initialization is also done. So this auto is attached by compiler, right? So what is this auto here? Auto is actually storage class. So whenever you have not given any storage class, then by default auto was attached. But this will be attached only if you have defined that variable locally, means inside any block, inside any function, either it is main function or user defined function or any block within main function or any one, right? So this auto will be called as storage class and automatic. So now this was already done by compiler, so you never worried about it, and we as a programmer were not worried about what is storage class. But now today we'll learn this thing in depth and we'll see why it is required, right? By giving this definition where you have written int I is equal to 12, I is a container that can hold integer value given its within its range of integers, right? So but in this case few things are still not clear. Like in hardware representation we have different type of memories like registers, cache memory, RAM, hard disk, USB, DVD, various devices are there. So now by this representation only int I is equal to 12, this information is missing. Which information is missing? That this variable is actually stored in which type of memory. Actually there are only two options. Actually there are two options only currently. That is, first one is primary memory and second thing is register. Or register memory also you can say, otherwise it is only register, right? These registers are actually owned by CPU. They are property of CPU. There are few fixed registers. Registers are of 2 bytes capacity, AX, BX, CX, DX, RX. So these registers are hardware devices. They are used by CPU for its own purposes. But you can store your variable in register also by defining its storage class as register. I'll tell you later. So one point over here is regarding the location of variable, where it is stored. This information is given by storage class. Other things are like this. So we have done this thing also. Okay, if we have given here only int I and not initialize any value, and then if I want to print, if I want to see what is printed over here, then it will be a garbage value. We know this. If I have not given any value to I and I will try to print value of I using printf, then it will print a garbage value, right? garbage value will be printed, right? It will give me garbage value. So this another point of information is default value, right? So there are two type of default values, either garbage value or zero. Zero is a representation, not saying every time zero. Sometimes it will be integer zero, then only zero, float zero, 0.0, double zero, 0.0000, more accuracy in zero, but zero is still there. In character, it is /0. So zeros are also of different type according to the data type, right? So this is second information. So first information is regarding storage location, either it is RAM or register. Second information is the default initial value. If you have not given any initialized value, then what value it contains. So it will be either garbage or zero, right? And the next information is about scope and lifetime. This is the most important information, the third point. I have written in my notes also in red color, all the 3 points that are giving me information about a particular variable regarding these points. So these are the few points. First point is regarding storage location. Your variable is stored in RAM or register. Default initial value can be either garbage value or a zero representation. That is, no value means zero, right? Scope and lifetime. Now, what is scope? Scope is actually visibility or availability, right? You can see like here. I have also told you about global variable and local variable. So these global variable, local variables are actually only defined by the place of their definition. Where you have given that thing within a function, if you have given any variable, then it is local to that function, right? If you have written suppose some variable inside this function, either in the parameter passing phase or you have written here int I, then this I is local to this f1, right? And if you have given this int I above all the functions in global area, then it is global. Okay, so the global variable is accessible by all, right? But in this declaration, whether you have given local variable or global variable, you have not used any storage class. So their scope is defined by their place of definition, where you have defined it. If you have defined it globally, its scope is global. It will be visible to all the functions, accessible to all the functions, right? Available to all the functions. If you have given it locally, then only it is visible within the function. I'm not talking about pointer variables, right? I'm talking about values by variables by their values, not by their addresses, right? So now the point is that with the help of storage class also we can specify this information, whether my variable is local or it is available to all, right? There are keywords to represent it, and those keywords is called as name of storage class. And another thing is alive or dead, means when you have created a variable, so up till which point of time it is available in my program, until my program is in execution, or whether my program is not in execution, still it is available, right? So this is called lifetime. Lifetime and availability or scope are quite matching, but there is a very thin line of difference between both of them. So this is only about the availability, but this is about the aliveness or dead, right? That particular variable is alive or dead. What is the lifetime? So this is also related to local and global. Obviously, we'll see some examples, right? So now you can understand storage classes are responsible for which kind of informations. These are within the 3 headings, but actually there are 4 informations. So first information regarding variable is its storage location. Second is regarding its default initial value, and third is regarding its scope, and fourth is about its lifetime, right? So now we have 4 type of storage classes in general. One more is there, that is called type def, and that is used with structures. When we will learn structures, then type def is also a kind of storage class. But here as a whole we can say we have 4 storage classes. First one is automatic storage class, second is register storage class, third is static storage class, and fourth is external storage class, right? And these are the keywords used to represent a storage class. So auto, is for automatic, register is for register, static is for static, and extern is for external, right? So what is the syntax to represent it? Syntax is same. Earlier you were doing only int I. Now you can do here along with int, you have to write here some storage class auto or register or extern, right? You can write here static also, so anyone. So now earlier what was there? Name of variable, data type of that variable, then one more is added over here, that is storage class. So now this is the syntax: storage class name, data type, and name of variable. Then a value is there, right? So example is there, auto int I. So I is the name of variable, int is data type, and auto is name of storage class, right? So now we will discuss all the storage classes with respect to all these 3 points. That means in automatic storage class, what is storage location, what is default initial value, what is scope, and what is lifetime. Similarly for register, what are the representations, all these 4 points. About static, again, what are the representations of all these 4 points, and what about the external also. All these 4 points will be discussed, okay? And some special qualities are there that will be discussed along with program. So see here, and we will complete it within this lecture only. So first one is automatic. As I have told you that this auto, if we will not give any storage class, then automatically it is assumed to be auto. But remember, when your variable is local, then only it will be automatic, right? But if your variable is global, it is no more automatic, because auto has property, it should be local to a block. So storage area is RAM, default initial value is garbage value, okay? Scope is local to the block in which variable is defined. This is the scope, because within that block only it is available, it is visible. And lifetime till the control remains within the block, right? So इसका जो scope और lifetime है वो block level का है, right? Block level means that block can be a function, that block can be a for loop wherever you have defined, or that block can be any pair of curly braces, that can be a block. I have told you that example also, right? So this is about automatic storage class. So we can see examples over here as fast as possible. If you have any doubt, you can ask me anytime. So here I have written every time void, right? But in according to your representation, now you should avoid this void, right? It should be only main. So here I have written auto int I comma j. So what it will be? Printf I comma j. I is not initialized, and it is auto also. If I'll not write auto, then also it is automatic, right? Then also it will be assumed to be auto, because this I and j are within a block, and that block is function block. So this is actually a block, right? Body of main is a kind of block. So I and j both will be garbage values, right? Similarly, in next example, it is written over here. See, in this example, blocks is also created, right? And I have told you anything from outer block can reach to internal block, right? Any information or any variable that is defined in outer block is accessible from inner block, but reverse is not true. That means if you have given some variable defined inside inner block, it will not be accessible from outer block, right? So how these blocks are explained over here? Let me take this example to programming part and explain you output accordingly. I'll share screen soon. Okay, see, I have copied here. Even if I'll remove these auto keywords, then also output will remain same, right? So if anybody has any doubt, you can ask me anytime. I'm explaining these things. I'm trying to indent it, but this is not necessary in C programming to provide this indentation. Okay, now it is correct. So within main, this entire thing is main block, right? Within main, auto int I is defined. Okay, correct. Then this block starts, new block starts, right? That block will go up to this point. To this point, this block will go highlighted point, right? So first line is printf I. Within this block, this is first statement, printf, and compiler executes from top to bottom. It will never take any line from below, right? So first this printf will execute. So its execution requires value of I, and I is not defined within this block. It is defined in the outer block, right? Within main block it's defined. I is 1, so 1 will be printed successfully by this. Okay, then after printf again I is declared, I is defined, automatic. So now I is 2. Now again next one more block has been started. This is another block. Within this block I is again defined with value 3. So printf will print I as 3 here, right? Because printf is having definition of I within the same block just above it. So what should be printed by this printf? This printf will not take I value 3 from inner block. This will take from the same block, that is 2, right? So output will be accordingly printed, and that will be first value 1 will be printed, then second 3 will be printed by second printf, and third printf will print 2. So accordingly 1, 3, 2 will be printed. Any doubt?
सर
No, sir.
Yes.
सर अगर सर कोई इंट डिफाइंड है, जैसे ऑटो कोच नहीं लगा तो वो अपने आप ऑटोमेटिक रहता है ना?
अपने आप ऑटोमेटिक रहता है, that is very sure. I started with this thing. If I have written like this, then it is auto, right? Now I will show you one more thing. Suppose you have written here, so j is equal to 21. Suppose you have written this thing, right? And you want to print it also. Printf %d, j. What will happen now? Anybody can guess?
सर एरर
एरर
Error. First, this is the output of previous.
आपने तो कहा था कि ग्लोबली में ऑटो कर नहीं सकते.
Correct. Correct. So this will be an error, right? I am showing this error. So this is the red line. This is error. Reason behind this I have already told you, and the reason you can see over here also error message is given. This error message, can you read it? Because font size is quite low and I cannot increase this. File scope declaration of j specifies auto, right? So this is actually contradictory. What is contradiction over here? You have defined j in global area. This is global area because this is not within any function or any block, right? This is global area. You have defined j here, so that means j must be accessible to all, and it is a global area. But the restriction with auto is that the auto will be accessible to local block only. So that means we cannot make any variable automatic in global area. If we'll remove this, then it is okay, right? Then it is okay. Then it will not add auto here. It will accept it differently. It will store in memory also differently.
तो सर अगर जो हम लोगों ने बाहर मेन के बाहर किया है तो ये किसी एक्सटर्नल किसी में नहीं है, किसमें सेव होगा? मतलब अगर हम ब्लॉक के अंदर कर रहे थे तो अपने आप ऑटो पे सेव हो रहा था, ऑटो क्लास पे।
Correct.
तो सर ये अगर बाहर कर रहे हैं तो किस पे होगा ये?
Actually, in RAM we have a memory mapping area, that is stack, heap area, global area, code segment, extra segment. Their global area is also fixed, right? So ये उसमें सेव होता है इस तरह से. इसलिए हम अच्छी प्रोग्रामिंग स्किल्स में we try to avoid global variables because global variables consume more memory separately. Any doubt, Shachi?
No, sir.
Okay.
सर
Yes.
सर अगर 9th लाइन हटा दें तब क्या होगा? 9th में जो कोड लिखा ऑटो एंटर ये हटा दें.
So now tell me what will be printed. Again 2 will be printed by this I also. It will see first within the same block, then it will see just covering block, right? So if I have removed this auto int 3, so this I will access I from this point, 7th line. जो इस ब्लॉक को कवर कर रहा है उस ब्लॉक में जाएगा. सबसे आउटर ब्लॉक तो ये है मेन वाला. Then within main we have this block, right? Then within this block we have this block, right?
Sir,
Yes.
सर ऐसा कर सकते हैं, ये जो ग्लोबल वेरिएबल है जब ये यूज हो जाए उसके बाद ये अपने आप इसे डिलीट कर दिया जाए, जिससे कि मेमोरी की भी दिक्कत ना आए।
यूज हो जाए देन
ये इसे डिलीट कर दें,
बेटा इसे
तो
कैसे?
ऐसा कोई कोड मतलब लिख सकते हैं सर?
नहीं नहीं नहीं, ऐसा कोई कोड नहीं लिख सकते हम। कैसे डिलीट कर सकते हैं किसी चीज को लिखे हुए को?
सर जैसे सब पॉइंटर में करते थे सर, वो बाद में नल बना देते थे उसे।
Actually, this is defined by C programming, that what type of variable will be stored in what type of memory, right?
यस सर।
So this is a rule, and we can access the thing with the help of pointer also. If you try to remove it, that value will not be removed,
यस
right?
Yes.
Pointer will point it, then there is a function called as free function, and then free function will remove that pointer, but value will be there. You are not going to access that value, but value will be there. You cannot delete it.
ओके
It
सर।
may be overwritten later on. That's a different story. We will discuss that thing later on.
यस
Okay, so this is automatic, all about automatic. Come to next point, register storage class. Register storage class, look, we have various kind of memories as I have told you, right? Register storage class are Ravi Sharma. Okay, so register storage class, registers are a special type of memory, right? And registers are called as smallest and fastest memory storage device, right? Or storage device. And registers are fixed with CPU. There are 15 registers and 20 registers. So we have fixed, they are fixed. They are not variable, right? They are fixed. And CPU uses registers for its own purposes. You can also use registers by making a variable like register int I. You can make a variable to be stored in register, but this is not a guarantee that you will get a register because it's CPU's own property. And if CPU has occupied its own register, then it will not be provided to any program, any variable, right? So what about this thing? Then if you have suppose defined a variable like you have written like this, instead of this register. So suppose you have written like this, right? Register int I. That means now I variable must be stored in any of the register. Register is within CPU, right? Register not like RAM. Register is identified by their name. So names are like this: AX register, BX register, and every register is of which capacity? 2 bytes. So which kind of values cannot be stored that have memory capacity more than 2 bytes? That means float and double cannot be stored. Even only short int can be stored. So this is register. So register int I, suppose you have defined, but CPU has all the registers occupied. So your variable will be stored in RAM now, random access memory, because registers are not given to you. So what is benefit of using a register? In current scenario, this is not so much essential to need to demand for a register for any memory requirement, because now cycle speed of system is quite high, RAM capacity is very high. So we generally never in such a condition ki we should have a register for our variable. But in earlier scenarios when C was being popular, at that time RAM capacity was quite slow, system speed was very slow. So registers were very useful, right? So what is a register? Register is like money kept on your upper pocket, or where you can access in the easiest way, but that pocket is quite small. That kind of thing is register. We will learn this thing in memory hierarchy, right? रजिस्टर एक उस तरह की पॉकेट है या उस तरह का एक जगह है जहां पर आप पैसा रखो, वहां से आप तुरंत ले सकते हो, कुछ इस तरह से आप समझे। तो रजिस्टर एक ऐसी मेमोरी डिवाइस है जो फास्टेस्ट है और स्मॉलेस्ट है, ठीक, लेकिन सीपीयू की प्रॉपर्टी है और वो सीपीयू आपको हर बार देगा ये जरूरी नहीं है। और दूसरी बात मैंने यहाँ पर बताई कि रजिस्टर्स को उनके नेम से आइडेंटिफाई किया जाता है, रैम को मेमोरी से आइडेंटिफाई किया जाता है। तो जो भी वेरिएबल आप रैम के ऊपर स्टोर करते हैं उसका अपना एड्रेस होता है, बट रजिस्टर्स का कोई एड्रेस नहीं होगा। तो ये सारी चीज़ें यहाँ पर पॉइंट्स हैं, इनको जरूर आप लोग एक बार देख लीजिएगा, अच्छे से कर लीजिएगा, ठीक। इसके बाद मैं आपको इसमें बताता हूँ अब रजिस्टर का यूटिलाइजेशन क्या है। एक छोटा सा एग्जांपल है, यहाँ पर हम उन वेरिएबल्स को रजिस्टर में स्टोर करने की कोशिश करते हैं जिनको हमें बार बार एक्सेस करना हो, मोस्ट फ्रिक्वेंट एक्सेसिंग हो इस वेरिएबल की, मोस्ट फ्रिक्वेंट एक्सेसिंग, राइट। For example, if you are running a for loop and for loop is running for 1 from I is equal to 1 to 10,000 times in any program, So you are accessing I so many times, so frequently. So instead of storing I in RAM, if you have stored in a register, then definitely the time consumption will be quite low and program speed, execution of program speed will be quite high. So this is a simple example of using register. Otherwise, registers are just for CPU's own purpose. Like I have told you, accumulator register stores the last calculated value, right? We will see some more examples regarding that. So now if I have told you that register cannot store a float or double value because their capacity is more, register is only of 16-bit capacity, right? Another thing, registers don't have addresses. So if you'll try to print address of any register, then error will be there, right? See this example I'm showing you again. Register, right? Here I have written I and suppose I have written J also. So this thing is regarding for loop. I don't need for loop. I know it will work. So I have written here, suppose I want to find address of I. So that will be an error because I is stored in register and registers don't have addresses. See, error is there. So what is error? See over here, error message is there. Error, address of register variable I is requested, right?
सर अगर यूजर इनपुट कर रहा होगा
हाँ,
वैल्यू ऑफ आई तो स्कैनएफ में हम लोग एड्रेस ऑफ आई देते थे जैसे,
yes.
तो सर स्कैनएफ कैसे होगा जब उसको एड्रेस पता ही नहीं होगा तो कौन सा एड्रेस वो सेव कर रहा है, मतलब ये चीज पूछ रहा है। अगर मैं यूजर स्कैनएफ करके दे रहा होता वैल्यू ऑफ आई।
Correct. Very good question. Very good. Scanf, suppose I have written here, right? You want to know like this.
यस सर।
Look, I have only explained you that how it will work. So now it is not working exactly, right? Address of register variable is requested again.
तो सर हम लोग केवल प्री डिफाइंड
Variable पे, हाँ,
सर
yes,
प्री डिफाइन करना पड़ेगा मतलब।
yes. User defined things cannot be done. Very good. So all of you, please remember this thing. Because we cannot access address of I, so we cannot use scanf for a variable to get a value from, right? Very good. Next storage class, static. This is a very much important storage class among all the storage classes. Static keyword. Actually, in OOPS based languages like object-oriented programming system, OOPS based languages, static means no copy of that variable can be created if static is written. In Java, we have written that main, public static void main, right? So here static is actually evolved in C language and then quite popular and utilized very much in other languages. So here meaning of static is like we are using here, right? So static stored in RAM, default initial value is 0. In case of register, you have seen default initial value was garbage, right? So register and auto are quite similar. Only one difference was there. Register variables will be stored in register and auto are stored in automatic. But in static storage class, storage area is RAM. Memory means primary memory. If I have not written primary, then understand this. This is primary memory. Default initial value is 0. Scope is local to the block in which variable is defined or globally declared. So wherever you have defined the variable with help of static, accordingly it will be handled. Right? Accordingly it will be handled. Then lifetime value of the variable persists between different function calls. Now this line is very important. And here one thing is missing. Write down at your own. The lifetime will be value of the variable persists between different function calls and loop iteration. Write down this thing about the lifetime of static storage class. Write down this thing that I have told just now. I am writing over here. Lifetime is actually value of the variable iterations. I'll show this thing. right? This is very important. In different loop iterations also value persists. Persist means retains. ये बनी रहती है, चेंज नहीं होती. तो चलिए स्टैटिक पर आते हैं जरा. अब जल्दी से स्टैटिक के कुछ एग्जांपल्स करते हैं. ध्यान से देखिएगा यहाँ पर. सपोज आई हैव रिटन हियर static int I. Static int I have written this thing, right? And one more thing, I have written suppose here int suppose int x. Written here for loop x equal to 1, x less than or equal to suppose 3 and x plus, right? Within this I have written this thing, static int I is equal to 1 suppose, and one more line I have written int j is equal to 1, right? Then here I have written printf. See carefully and note down also these examples. Send d. So here I have written I is equal to, and here j equal to. Then I have written I plus plus comma j plus. See. So what will be output of this program? I am executing this, and we'll see effect of static over here. Which one variable is static? I is static. J is not static. That means J is auto, right? J is auto. So this loop will run 3 times. So 3 times these lines must be executed, body of loop. But as per the definition of static, okay, value of the variable persists between different function calls or loop iterations. So you can see output over here, but instead of doing this, first I should write here /n so that it will be more clear. So every time printf will be written on next line. So what will be here its representation? If I have written static, so I will be initialized only once. Loop will run 3 times. So this line must run 3 times. Static int I equal to 1, int j equal to 1. But due to static, compiler will not initialize I 3 times. It will initialize I only once. So output will be I will be first 1, then next time I will be incremented. So you can see output and understand the difference of static and without static, right? Because of this, I initialization is only done once. It's this definition is also there. So all the 3 things I'm showing here: lifetime, value of the variable persists between different function call or loop iteration. So what is meaning of this thing? In the, between loop iterations, I is this initialization is done actually 3 times when loop will run 3 times, right? But as compiler looks here that this I is static, it will not allow to initialize second time or third time or fourth time, right? So when I is initialized with 1, j is initialized with 1, I1 and j1 are printed, I is incremented to 2, j is also incremented to 2. But next iteration for x equal to 2, again this line is should be executed, but initialization of I is not done. So I is 2 earlier, right? In previous iteration when I plus plus was evaluated, then I was 2, but j is normal variable. So whatever j was incremented will be initialized again. So j will be 1 again, then I will be 3, j will be 2 because j was 1 now. Again it will execute. Again I initialization will not be done. It will remain 3 as it is, but j will be initialized to 1. So j every time 1 and I will be 1, 2, 3. Anybody has any doubt regarding this example?
सर
Yes.
सर जैसे स्टैटिक इंट है, इसकी जो फर्स्ट इनिशियलाइज होगी वैल्यू y इक्वल टू 0 पे होगी.
0 क्यों? I have given 1.
नो सर, अगर सर वैसे अगर %d डायरेक्ट 0 प्रिंट होगी तो सर ये
0.
तो सर ये अनसाइंड के तरीके वर्क करता है कि साइंड के तरीके?
Why?
सर मतलब 0 है तो मतलब ऐसा नहीं कि मतलब आगे की वैल्यूज लेता हो पीछे की वैल्यूज ना लेता हो, 0 नेगेटिव वैल्यू ना लेता हो जैसे साइंड होता है.
No, if you will write here minus I, it will start decrementing.
ओके.
Anybody else? Everybody understood this concept of static? So I'm coming to the next example about this function call, right? Okay. So about this function call, now I have one function, right? I have made one function. Suppose I have made here a function f1, right? And within that function, I have given here suppose that function I am giving here int I is equal to 1, and then I have written printf %d. Suppose I have written here slash n also comma I, right? And inside main, what I will do, I will call that function. Inside main, now I'll call that function, right? So I have called this function once, then I have called this function twice, then I have called this function thrice, right? So everybody tell me what will be output now? What will be output of this program? So it will be 1 3 times. Okay. Anybody else? Any different output? I have called this function f1 3 times over here. So output should be, function will be initialized, right? Function will execute its both statements. So initialization will also be executed, right? So first initial execution, I is 1 printed, then again 1 printed, then again 1 printed. So 3 times function is called. So 3 times body of f1 will execute, and 3 times it will print 1 1 1, right? This is the output. Okay, now there is a change. Suppose I have written here static. But still there will not be any difference, right? Instead of
I plus plus.
Okay. Yes, I must do here. At least I should do like this. So if I'll execute this again without using static, so again it will print 1 1 1, right? Then next time I'll make it static and then execute it. So now it will print 1 2 3. So this is the role of static that you have seen. The value of the variable persists between different function calls or loop iterations, right? So meanwhile it will execute, right? It is executed without static, right? So I'm closing this. Again, I have executed this with the static. So now output will be 1 1 2 3. Anybody has any doubt, please ask in between, or static is clear to all of you. Anybody is having any doubt regarding static keyword? This static is a storage class, and the definition of static is in lifetime, that is value of the variable persists between different function calls or loop iterations. So this output is 1 2 3, right? So using this static and its own property, Fibonacci series logic I have again written over here. See this once. If you are not getting it, please tell me. What is done over here? This is iteration based Fibonacci series representing. So in Fibonacci series, our two terms are fixed. So that I have written here, a equal to 0, b equal to 1, and I have made it static. So that means in for loop, when Fibonacci series fib term function will be called many times, so every time this initialization will not be done, right? And this simple logic will apply. So what this logic is telling me, a plus b is the third number, right? And second number will become first number, and third number will become second number, right? So it will not initialize again and again, and successfully my Fibonacci series will be printed. Note it down or take its screenshot if you want to take this Fibonacci series function. So this is with the help of static keyword, how Fibonacci series can be printed nicely. Or other thing is that you make these two variables global, then also it will work. So in comparison to making global, static is more beneficial. according to the memory point of view. So I have executed this. If you have any doubt, you can ask me. Here various things are limited. So here suppose I want to print 7 elements of Fibonacci series. So it is there, right? Successfully printing. Okay. So come to the last one. So these examples are mentioned over here also. You can go through them. External storage class. So about external storage class, right? Keyword is external. If storage is memory, obviously RAM again, default initial value is 0. Scope is global. Every function can access it because it is given in global area. Lifetime as long as the program is in execution, right? Not a block of program is in execution. Here program is in execution. So external variables are global, so are declared outside of all functions, yet are available to all functions that care to use them, right? All the global variables and functions by default have external linkage, because functions body is given like any global area, because we cannot define a function within another function, so they are global defined, right? So here I have shown few examples also. One more thing, global variable and external variables are little bit different. How you can say this thing? A global variable is different than external variable. External variable will be defined with the help of external keyword, first thing. Second thing is external variable can be defined above its definition or below its definition, right? Above its declaration and below its declaration. So now there is one more important point that I just remembered, right? That what difference between declaration and definition can be given with the help of external keyword. I have told you that whenever we declare a variable, memory space is not reserved, right? I have told you this thing. So one example I have written over here. Okay, this example I'll show you. So suppose I have written this example, main extern int var, then this is the thing, right? So I have written here keyword variable defined as extern, right? And variable is defined below. Then also it will successfully. And this is the point where not obtained any not obtained memory space, right? Because this is extern. So extern will only, so this is called a declaration. This is declaration. So in declaration and definition, there is a difference, that in declaration, variables will never get memory space reserved for them. But in definition, memory space is also reserved. So at the time of definition, you can store a value in it, right? So here I cannot give a value. If I'll write here, suppose this thing, then this is an error, right? I cannot do so. But this is correct. And if I have written here int var equal to 200 after main, then also due to external linkage, it will run successfully, right? It will run successfully. Or I can write this thing above main. I can write this thing above main also, then also it is correct. But I cannot give it at both places, right? So this is external. Storage class of var is external. Now linker will link its definition from outside of this block, right? Within same program, or if you have created a project and you have two programs, then within one, and both the programs are stored in same project file, right? So how you can do this, if you have written here, this is new, so new then project, right? So in this way you can go through with this also. You have to create a project, then you will create a C file and it will ask you to add it within the project, right? So that example is also mentioned in my notes, right? So this thing is okay. If you have written here at the top, then also it is okay. So then also it will work. But global variables must be given only above. But external variable can be defined above also and below also at both the places. So it is okay. So this is executing without any error. So it is taking time to execute. right? Here in this program, you can see X is global variable, right? So this is actually output of previous program that I have given here, right? Where is given above, then also it will work successfully. And then in this program, I am saying you that int x equal to 21 is a global variable, right? Okay, x will be printed because of this, but extern int y and int y is equal to 31. They are external definitions and linking, right? And linking also. In global variables, we don't have to write that thing again, but in external variable, we should write again. So first thing here, extern int y means y is only declared here. This is declaration of y. This is declaration of y, and this is definition of y. Right? That means global variable must be given above, and external variable can be defined anywhere, either above or below. And in my notes, you can see over here that I have given this thing also. Within the same project, I have created two programs. One program I have made 1.c, another I have given 2.c. So in 2.c, I have defined a variable int equal to 20 globally, obviously not within the function. So you can see now program output is there. This output is for this program 2131. They are printing successfully, right? But suppose I have written this thing below, right? I have made this thing as a comment, and then I have made here, right? Then what will happen? Then there is an error in x, because x is not external variable, so it cannot be given below. It is showing undeclared, right? So in normal variables, we should use that sequence: first definition, then usage. But in external variable, compiler will wait, and your definition can be given either above or below or in another program also. So here you can see, right? Here I have given in this PDF a extern int a, right? And a is defined in this file 2.c. Okay, it is also working. So now the point is that use static when and why. Only if we want a variable to persist between different function calls, use static. Register for a variable used often, very often. Extern is used when we have defined things in some other file, then extern is utilized. And if you don't have any need mentioned above, then auto is automatically done. So now you have to prepare theoretically and programmatically also this concept and go through with this summary. I have written this summary also, right, about all the storage classes. And one more storage class is remaining, that is type def. We will discuss this with storage class with structure.